Welcome to the Human Odyssey, the podcast about human-centered design. The way humans learn, behave, and perform is a science, and having a better understanding of this can help improve your business, your work, and your life. This program is presented by Sophic Synergistics, the experts in human-centered design. So, let's get started on today's Human Odyssey.
Hello and welcome to the Human Odyssey podcast. I'm your host, Lisa. I'm here with Cynthia, Brittany, and our guest, David Gabriel. Today we're going to be exploring how virtual reality can benefit human-centered design. Our guest today is David Gabriel. He is an Army veteran and an industrial designer working as a VR developer and human factor specialist in the Dynetics Space Division. Thanks for joining us today, David.
Hey, I'm happy to be here.
Glad to have you. So for everyone's understanding, I wanted to briefly describe VR, kind of define it out. So it's a computer-generated digital environment that can be experienced and interacted with as if that environment were real. And this kind of brings us to why VR is a crucial component in human-centered design in certain industries, because VR allows stakeholders and users to experience that environment that maybe has yet to be built, or that might be unsafe, or that really maybe just is difficult to access. It provides an excellent opportunity to prototype and assess design, and is a great resource for user training. So this kind of brings us to another component of human-centered design, and why it's crucial is that it can provide quite a good cost savings to businesses. And I don't know, Cynthia, if you wanted to speak to that.
Yeah, and so, I think the key here from a human-centered design perspective is early and often. And so we're always looking for new fundamental ways and innovative ways to get at aspects of user concerns, constraints, and, optimization in the most cost-effective manner. And so, AR, VR, and, what's coming down the pike, where you have kind of this blend of augmented reality to where everything is a little bit more integrated, brings with it a whole host of, promising type of activities that you can do without even cutting metal. And so it allows us to, the word agile gets thrown around a lot in design, and it allows you to do a lot of rapid prototyping and a lot of iterative design, almost, within seconds, minutes, and sometimes overnight. I don't want to go too far because it is really hard to render environments in VR. So I don't want to minimize that, but it has incredible utility, and it has limitations too. So I think this discussion will be really interesting for those who are stakeholders in AR/VR, and also are interested in how it applies, across industries.
So that brings us to some of the different industries that VR is used in. It's used in a wide range of industries, including oil and gas, aerospace and aviation, architecture and construction, and the government also uses it as well. And now companies are using it to train their employees, where, as I mentioned before, in certain situations that could be unsafe, such as like a fire, and you're trying to train the employee how to exit a building, or just situations that are difficult to access, that you're able to train and really put the user in that environment so they can experience it as it would be. So that kind of takes us to especially VR in aerospace, as we have Gabe here with us. I was wondering, Gabe, if you could kind of just talk about why VR is necessary for aerospace, and particularly the prototyping that's done.
Absolutely. So, I've been able to implement VR in a way that really assists the conceptual development. Everything typically starts off as, a napkin sketch somewhere, right? Somebody's got that initial idea, and it's really important to foster that looseness in the beginning as long as possible, because that's where your design really can has the opportunity to change in extremely dynamic ways before you start to add the the overwhelming amount of engineering requirements and restraints to the design. So before you ever bring it into CAD, before you ever get to, have to do something like that, you have this sort of magical time where you can, affect the design. And this is really where I've found that VR has been extremely helpful, because, we were able to take something that needs to be human centric, and we can bring it into VR, and we can introduce a human element before we have any other requirements or restrictions. And if you can start from that position, then the compromises that you make, that you know some of the consequence. You never know everything, but you at least begin to have an understanding of the compromises that you're making from the human perspective. And I think it's incredibly powerful to start from that position instead of levying all of your requirements against the human needs. You start with the human needs and then work your way back from there.
Yeah, that's a great point.
Yeah, and Gabe brings up a lot of interesting points. I think all too often in design we get stuck on driving requirements with solution, and the time frame that he's talking about is like a really sweet spot in design where you have the ability to let creativity run free, but also gives you the capability to do those initial assessments, pro con assessments of what types of designs could pass muster and make it through to the next iteration without kind of putting all your eggs in one or two baskets before you've had the ability to run through a lot of different design permutations quickly to identify where you're going to have the major roadblocks or not, and pursue down that lane. And again, that also helps you hone in from a cost effective perspective pretty quickly versus spending a lot of time building functional mock-ups.
Yeah, Gabe, can you walk us through a little bit, if people haven't had experience with, what it takes to be able to introduce, a human model into a CAD model in VR? Like, what is a little bit of that behind the scenes work that has to be done in order to have that human modeling capability within VR?
Sure. So, there's programs out there that exist already that will give you some human modeling capability. Um, like Gravity Sketch, for example, has a mannequin already that is fully posable that you can size to whatever anthropometric needs that you have. Um, and there's a way to bring in additional models that if you wanted a spacesuit, you can do that. It does require some understanding of it. It starts to blur the lines a little bit, where you're not necessarily working just in VR. You start to have to know a little bit about like animation and how to add bones to a mesh body, and inverse kinematics, and you have to understand a little bit like how the body actually moves to start to set it up. So um, you know, like a little bit of just general understanding of the human skeleton and things like that are really, really helpful. So once you kind of get past that, and so like in my experience, I've had to teach myself a lot of how to set up some basic animation, because there's that overlap between them, and not just overlap in that understanding, but overlap in a very technical sense, because traditionally animation has been done with for the things you see on TV like Pixar and things like that. It's done with what you would call mesh-based modeling, and that means that it doesn't have any parametric data to it, and parametric data basically means that you haven't assigned specific measurements. You could scale a mesh model up or down as much as you would like. It doesn't care. But a parametric model, has very specific, data attached to it for how big or how small any part of it is for tolerances. So it makes it tricky to bring a very advanced engineering model that is, has screw bosses and everything, that has extremely tight tolerances, and bring that into this almost squishy environment with a mannequin. So you there's definitely ways to do that. Like, you can convert that model into a mesh model and things like that. But that basis of starting with, the mesh modeling, that's what VR likes. Also, just from a rendering perspective, if you bring in a model that is straight from a SolidWorks program or something like that, or Creo, or CATIA, or any of these, the major modeling softwares, they're not optimized for VR. So you do run into some limitations where VR can't necessarily render it exactly as it was built. But there's lots of ways to work around that. And as the technology keeps getting better and better, we have more and more tools to do that. Um, but yeah.
It's something really key, I think, too, in terms of thinking about the benefits and the utility of modeling in this environment. And so, human movement, especially in aerospace, is very different than what we're used to terrestrially. And so, even within different space environments, like when you think about low Earth orbit, and then when you think about lunar gravity, and then what we're going to experience Mars, they're all different in terms of how they impact how we move. And so, these things are really hard for us to replicate, even with the best mock-ups and situation on Earth. And so, VR, AR gives us the ability to put this into a digital space where we can float and we can simulate to the best of our abilities based off anthropometric models of how people will fit into a space and potentially navigate and where there are impacts. And also, there is an element of considering behavior and how it changes. And I don't want to minimize this utility for on Earth, because the behavior component comes in terms of how people interact and move here on Earth, but it's a lot more complicated from a design perspective and a lot more expensive to try to model it for aerospace.
Yeah, and I think it's important to note too that, we're not saying that VR or AR environments completely negate the need for physical mock-ups or prototypes, but it does give you that agility. Going back to, that word you used early on, Cynthia, agile, and it gives you that ability to include the human in that conceptual or beginning stage. When you're making foundational decisions about how something is structured or how it's laid out, you can incorporate the human models into that story early before you have access to mock-ups or prototypes.
Absolutely, and especially for VR, your next stage after that would be like a low fidelity mockup, right? And you would still want to verify all of the things you think you learned in virtual reality, but ideally, you would be much further ahead, because even, if you're going to make a lo-fi mockup, you still have to build a model of it, you still have to get it ready to manufacture, and all that stuff, and you can bring that into VR. And you can say, okay, this is what we're planning to do. These are the tests we want to run. Let's bring in our mannequin and just, make sure that this is all working out correctly. And you can just do that as many times as you want. So by the time you actually decide, okay, here we go, we're going to make our mock-up now, you can go into it with a reasonable sense of security that the next step you're taking isn't going to require a lot of backtrack. That you've vetted this design as thoroughly as the technology will allow you right now.
So that kind of brings us to our next point that we wanted to talk about, that VR does have some hurdles. And one of the major ones that causes users to not accept the technology is discomfort. And that is definitely a problem that needs to be considered when VR is designed. And I was wondering if you could kind of speak to what kind of ways you can kind of design out discomfort or minimize it when you are developing VR.
Sure. Yeah. So part of the reason people get discomfort is from the environment moving without them moving, right? So if you do what's called seamless locomotion, and you just press a button on the controller and you just start to move in that direction, that can cause a lot of discomfort. The other way is often not having high enough frame rate within VR itself. So it's really necessary to keep the frame rate above or around 60 to 90 frames per second. And that can be a little tricky given just our technology limitations and what platforms you're running it on. So if you have a large desktop that's got all the graphics cards, in the world, um, you're going to do a lot better than if you're trying to run an application on an Oculus that isn't connected to anything, and all the processing is done right there in the headset. Um, so the way that I navigate that is I generally don't use seamless locomotion, just because for that reason exactly, that it tends to cause people discomfort. And ideally, I want the environments that I create to be able to be used by anybody. So what I do is I use a teleport feature where you can shoot an arc in a direction and it just teleports you to that spot. And it is an unnatural way of moving. So it makes you sometimes aware that you're in VR, which is something you're always trying to avoid, right? You're always trying to keep people sort of forgetful that they're in VR. But I think that people quickly adapt to it, and they can, just sort of take that in, and then their brain just kind of clicks and says, "Okay, this is how I move here," and they just go about their way. Um, so that really leaves frame rate, and that's up to the designer or the person creating the environment to monitor and make sure that everything is working out. And there's tons of ways to do that. Different kinds of lighting can affect your frame rate. Different kinds of materials that you want to render can affect your frame rate. The size of your models. Um, there's ways that you can bring in like a rectangle and then put stickers on it essentially and make it look fully textured or like a much more complex shape without having to actually bring in a model with all those edges that have to be defined. So if you actually go into VR and you play any of the games that exist, on the Oculus headset, one of the good ones for an example like this is I think it's called Robo Recall. You go around, you shoot a bunch of robots, but there's a lot of great lessons to be learned in that where there's things you can grab and interact with, and that's where I decided to use teleportation as transportation, is because that's what that game has, and it works really well. And you can look around, and there's like cars and walls and things. And if you get up close to any of the vehicles, you'll see it's a very simple shape with a rendered sticker on it, essentially. But from a distance, you don't really tell that that's the case. So having what you would call levels of detail is really important, and you can even do stuff where the things that you're close to are rendered really well, and as they go out into the distance, you don't need as much rendering power because you can't really see it anyway. So as you get closer to it, you can make that particular thing come into focus. So there's lots of ways to optimize VR for comfort, and to accommodate whatever system you're running on.
Yeah, and before we leave this point that I think is pretty universally important to every industry, because a lot of industries are also looking at this as immersion training when you can't put people into the environment even on Earth. When you think about surgical suites, you don't want to train somebody necessarily on patients as the first time, and so immersion into the environment is pretty key. And we've actually helped some of the tech companies work on this a little bit in their design of the goggles. And again, when you think about the human form, it's very dynamic, and so there's even challenges within the same person on any given day based off of how your body composition is. And so the goggles might fit perfectly for your face and form one day, but let's say the next day you might be dehydrated or experiencing some other element of fluid shift in your body, and now the goggles don't work so much for you. So I think the industry is really looking hard at how do you do this a little bit differently too, to maybe wear goggles like that are not required to impart that immersion effect. And I think that's also going to be key when we talk about environments like aerospace for training, you know, like forget design for a second. How do you get people who aren't traditionally astronauts or don't necessarily have space experience ready to go and feel like they've had that experience in a training perspective?
Yeah, absolutely. Even just the hardware, it can be an issue. You've got like your sinus cavities all right here, and that's right where the mask goes. So exactly like what you're saying. There's days where I'll put a headset on, and it's just very uncomfortable. And there's different companies that do it better than others. Like the Oculus 2 is definitely better than the Oculus 1. The Vive headset is slightly more comfortable than probably both of them. But right now, it's like we're limited by how small the technology can be. And again, going back to like, what kind of system are you trying to develop for? And that will dictate, how much weight you have on your head. Also, like neck strain, eye strain. Typically, though, eye strain in VR is much less. But yeah.
From my understanding, the more a user is able to kind of interact with that environment, the more that can also help with discomfort. Is that kind of your experience as well?
Well, so I've done. So I was in a virtual environment that was a mock-up of a space station, and you were in a zero-G environment, and the way to move around, you had to actually grab onto handholds and things like that, and it it's still a little tricky, like even for me, and I spend a reasonable amount of time in VR, uh, to grab onto something and then like push off from it, but still know that my body isn't moving. That can that's still, I don't know if that helped or not, because it was like starting and stopping, because it was like you grab it and your body is supposed to, you're moving, and then you stop, and you almost want to like move forward after you've stopped yourself. Um, so I'm not sure. I know that in a terrestrial environment, when you have the floor or something like that's really helpful. But you have to come up with clever ways to change the floor level. Like if the floor isn't a perfectly flat surface in your virtual environment, but the world that you're living in is a perfectly flat surface, how do you make that transition, right? Like how do you go up a set of stairs, um, but also not have those stairs exist? So um, again, this is kind of where like the teleportation method works really well. You can kind of, jump up where you need to go. And I think the brain accepts that pretty quickly. And then seamless locomotion, if you were to use that, you kind of just glide up the stairs. So it's tricky. And then I've thought about like, well, what if I could sync up the VR environment with the real world environment perfectly, and I could have a set of stairs built here and have it line up exactly with where the stairs are in VR, then maybe that would work. I haven't figured it out quite yet, but I think it could work. But I think you start to do that too much, you're gonna run into safety issues, because no matter how perfect you make it, there's still a chance that you could trip on a regular set of stairs without it being in VR.
Well, and I think you're sort of making the case for like a blend, right? An augmented reality situation too, to kind of help with like that next generation, leap once you've kind of exhausted the utility of VR, right?
Absolutely. And that's really where it's important to remember, like, is this a good application for VR? And it isn't always a good application. And AR has an entirely different set of uses, but they run very similarly from how you build the environment, how you develop the UI, how you treat it. is extremely similar. I think of them really as like siblings when it comes to development, because a lot of the especially the UI opportunities that you have in VR translate extremely well over to VR. Now, one of the things that is nice to do in VR is to keep things similar. So, like if you wanted somebody to go through a door, you would want to have them reach for a door handle. If you want somebody to interact with, a computer, you would want them to go up and push a button on the computer, because you can do that. If you're doing an AR environment, you can still do that, but instead of creating the door and creating the button on the door, you can create a signal that highlights the door handle, or the button on the computer that you want them to push. So the way you do it, I think, ends up being, or can end up being, very similar. What ends up being a problem, I think, in VR is, instead of taking advantage of this idea of keeping somebody in VR mentally, they'll throw impossible screens in impossible places sometimes, or you'll have buttons that just pop up out of nowhere, when there's opportunities to put them in places that keep the immersion alive.
And I think a lot of what you're bringing up too is a phenomenon in human factors, human centered design. We that relies on mapping. So mapping your expectations, mapping your understanding of how the environment works to kind of get at that seamlessness indirectly.
Yep, absolutely. And it doesn't always have to be that way. There's definitely there's opportunities in VR that you would want to go beyond exactly what you would find in a real world environment. But I think it's just, it's important to go back to those scenarios and say, is this helping the environment? Is this actually making it more immersive? Is it making it more enjoyable? Or is this, does this feel unnatural to the user?
Yeah, another good point. What's your objective?
Yep.
Brittany, did you have any other questions?
I guess just switching gears a little bit, talking about logistically kind of how does some of these things work, especially when we, think about these big integrated design projects. There might be multiple different entities working on different areas of the design. So how do we get everyone together, to be able to look at one integrated CAD model in VR. So Gabe, can you talk a little bit about the ability to collaborate within VR, virtually without being in person? How do we get, people to assess an integrated design solution?
Yeah, absolutely. There's several options for that. One of them is Gravity Sketch. They have a creative room that you can bring a model in, and several people in from all over the world into the same space, and review a model, make notes, and create whatever models in it that you might like. Like, for example, if you were looking at a car model, you can bring the stakeholders into that room, and they can draw notes on the car, or they can move steering wheels around and do whatever in a collaborative environment, which is extremely powerful. And I know people I have some friends that work at General Motors, and I know they use this program a lot, and it's pretty cool. Then Unity is another rendering engine, as well as Unreal Engine, and they both have ways to do collaborative spaces through their own servers. Where it gets a little tricky is when you run into like security requirements, and how do you keep your proprietary data proprietary, right? So it really depends on what I think your security needs really end up being the biggest driving factor for collaboration.
But there is that ability to, with minimal hardware, bring in people to assess, without flying someone in, and they get that immersive experience. You said something interesting too that I wanted to touch on, because I think one of the important abilities of VR is not only to be able to assess design from like a functionality or an engineering perspective, but from the stakeholder, buy-in perspective. I think if you have a design solution that you're trying to, argue that might cost a certain percentage more or is divergent from, the current baseline, I think being able to bring in decision makers or customers into that immersive space and give them, that experience, you can better, make your case and communicate your vision. If there's justification or rationale behind, why you want a certain change, it's easier to communicate that by seeing versus just, going through a chart deck or data.
Oh, absolutely. You put a headset on somebody, especially somebody who's never been in VR before, and they're just like, oh my gosh. Like if you could see their eyes, their eyes are like this big. And it's pretty exciting to get people in for the first time, especially. But I think it does another thing aside from just the wow factors. I think it builds trust in that you can actually walk up to this design. It exists, even if it's just in this virtual environment. You can sit there and look at it and say, here it is. And any doubts that maybe they couldn't make it or they couldn't do it this certain way or it needed to change to be something else, you can make pretty strong cases right there. It's like you've got levels of that convincing where you can put a proposal together and give them a written document and say, okay, here's a bunch of words and it means that I can do this thing or that we should do this thing. And then you can, make a CAD model and you can make some renders and have a still image and you say, well, here it is. Here's the idea. And, that can, bring some buy-in as well. But if you can get them into a virtual environment to see it in all its glory and get them to walk around and interact with it, that's just like the next step,
Yeah, I think if a picture is worth 1,000 words, VR's got to be worth 1,000,000.
Yeah.
All right, I think that closes up our topic today with virtual reality in relation to human-centered design. Thank you for listening to the Human Odyssey podcast. Check out our social media platforms for more human-centered content.
The Human Odyssey is presented by Sofix Synergistics, the experts in human-centered design. Find out more at sofixsynergistics.com. Get smart. Get Sofix smart.